What's up, guys? Let's catch up on day 7 of Advent of Code. This one's called Bridge Repair. We've got these lines with a value on the left they call the test value. That is our target we're trying to hit, with the values on the right as some operands in an expression. So in part 1 we have only 2 possibilities, add and multiply. So we could say 10 plus 19, no. 10 times 19, yes, that line qualifies. If we have more than 2 operands, then we have more possibilities, because there could be a plus or times here and a plus or times here. So how long do the lines get? Well, over 10, but it's not like 100. So we're going to try brute force and maybe a few optimizations if we can. Let's see how it goes. I've got a little bit of code as a setup. Let's see how we're starting. We're parsing the lines as the left of the colon, which is our target. They call that the test value. And then the right, which we're calling the operands. So if I do that, I partition and then I split, and then I'm calling that equation. Okay? Our type annotations are our focus this year. I didn't start that way, but it's turned out to be my favorite. So equation is a tuple of int, the left, and operands, which is a list of ints. We don't know how many, at least 2, but it could be more. And then if we print that, you'll see that we've got, okay, the first line is 190, and then the parts, 3267, and then the parts, and some of the numbers are pretty big. So what are we going to do? We're going to pass that into part 1, and our goal is to say the left number, the test value, of the ones that could be possibly true. So after checking all the combos of operands between them, or operations between the operands, then if any of them work, that's toward our total. So I think this is going to be a sum of a map of something. We're going to call that calibrated because that's what they call it in the lore of the text. And then equation, wait a minute. Yeah. I was thinking, are we getting the whole thing or just one line at a time? Well, the calibrated is just getting one line at a time. So it gets an equation, not a list of them, and it returns, well, we could do a bool, true or false, is it qualified? But then we'd have to add up the numbers anyway, so let's skip that and just give it the number if it's good. If it's not, we'll give them a 0, and that'll contribute to the sum, or it won't contribute to the sum. So what are we going to do here? We're going to destructure it, peel it apart, because I don't want to use any indexing. I don't want to say equation 0 and equation 1. I want to make it nice and pretty. So they call that the test, and the operands, or at least that's what I'm going to call it. And then we've got this idea of what are all the combos of the operations. Well, first, what are the operations? We're going to treat them as functions. I guess you could put symbols in there and then try to eval, but they have this weird rule about no order of operations. So like if there's a times and a plus and a times and a plus, we just do them left to right rather than imaginary parentheses. So why do I keep doing that? Let's just treat it as functions. And I'm going to make them because, as you've seen, I'm focusing on the types. And if I import add and mul from the operator module, they don't have type info. I think they take any, which is kind of annoying. So this takes A and B, and it returns an int. And we can still do it as one line. And then I'm going to do the same thing with mul. A lambda would also not have type info. I think if you tried, it would have a syntax error because the colon would also mean the colon of the lambda, you know. But I haven't tried. I don't know for sure. Okay, so I'm going to call what should we call the thing of how many ways we can arrange it? I'm going to call it strategies because that sounds cool. And that's going to be, well, how many do we have? It depends. So I'm going to use the itertools product, which I've used recently. So we're going to say add and mul, and then repeat, which is how many times we can do it. We're going to say len of operands minus 1. I think that's called like the fence post problem or something, where if you have two things, there's one gap between them, or if you have 7, there's 6. It's always one less than the total in a row, you know? So what is product? We got to import, and that'll be fine. So let's say we're going to test the different combos, right? We're going to say for strategy in strategies, if one of them works, then we're good. And what is all the working stuff? Well, I'm going to put that in a separate function because it's a lot. I don't want to like do 7 more levels of indenting or something. So we'll call that calculate equals test, then we return test. And if we've got through all of them and nothing succeeded, we return 0. It has to be 0, it can't be none, because we're putting it through the sum function to add it up, so it has to be summable. So now we're going to say, okay, how about the calculate function? It takes, well, we know what it takes because we just wrote that. Operands, which is operands, and then strategy, which is what? Well, I'm going to call it operations because the idea of the math thing, you know, whatever. So let's go, okay, what is the idea? Sorry, I'm trying to type and think and look ahead. So this is like, okay, I'm going to give you some functions. They are add or mul now, but in part 2 it's going to be more possibilities. So let's give those some types. Operation is a callable, specifically 2 ints to another int, because that doesn't change. And that's why I needed to make my own add and mul, because if I import the add and mul from operator, it's not going to happen. Okay, so we need to say from typing import callable, and then we can say operations, which is the unit we are passing in, is a tuple of, well, right now it's always 2. It's always add, or mul or something, but that's only on the first line of the first part. It could be others, and we don't know. So when you don't know, a tuple, unlike a list, like when you say list int, that's any amount, but a tuple is more concrete. If I say 2 ints, that's different from 3 ints. So if you want to say it's like, oh, it's some amount, you put the ... I think. So now let's try to actually do it. We're going to say, okay, I think the old classic way to do this would be like a stack. Like we take the operands and reverse them, and then we pop off 2 and then do something to put back 1. But I don't like that. So instead we're going to go through in order with the iter function to make an iterable, I can never remember, but I'm going to call it Q, which is like the line of guys we're going through. So iter of operands, and then the one that we're working on, like the current thing, I'm going to call that register, because that's kind of what you call it in the CPU, even though this isn't real, is next. So next is like the pop kind of on a list, except it comes from the front, and we can just go in order without having to worry about like putting some back or whatever. So we can say for operation in operations, we're going to go through the tuple, so like add and then mul, or mul and then add, or add and then add, or all the possibilities. And this means that we don't have to worry. Usually if you're calling next on something, you have to worry about, am I going to have an error if I call and it's already empty and then I have to handle that. But this for loop is going to protect us because we know there's the right amount of stuff in the for loop. So we're going to say register equals operation of register and next queue. So this is like, if I've got 10 and 19, I take those, I go 10, put that in the function with 19. And then my result would be called with the next guy, except there isn't one. So on the next one, it's like 81 is our register, then we take 40 and put it through maybe the plus. And then we take that and peel off the next one, 27, and put that through, whatever. So it's kind of like a reduce function, but I didn't use the word reduce. And then we're going to say we return the register. I wonder if we could use reduce. Maybe not, because it's a different operation every time. It's not like just plus all the way through. Okay. So let's see if that works. I know I haven't been printing with tests, but let's just run it and see what happens. So that says 3749. Is that correct for the, oh my gosh. Yeah, 3749 is correct for the test on part 1. So 190, that qualified because you can multiply these. 3267, that qualified because you can do certain combos of plus and times to get the answer. And then this one, same thing. There's only one way to do it. It seems like you might have more than one way to do it, which is great because we do early return, right? Like we're not trying every single thing before we check any of them. We're checking each one along the way. So if the first thing works, then we're not trying all the other possibilities, and that's great. That's slightly better performance, although this is not the best performance, as you'll see when I run it on the big one, especially part 2. Let's run this on the big one, see what happens. And we'll see 265 and then a super big number. Was that it? Yeah, that was it. So now part 2 says, hey, you know what? It's all the same thing. Totally the same idea, except we have 3 operations. We have plus, times, and concatenate. So if it's like 12 and 3, 4, 5, then we put the digits together as if they were strings. Even though we started with ints and we end with an int, it has a little stringy step in the middle. So, okay, let's do it. It's almost like a dare, like, hey, is this going to work? Is this going to be performant? Is this going to take 7 years to run? And, you know, whenever that happens, we'll just try it the long way, and then if we have to optimize, we can. So what I'm going to do is I would like to keep, okay, calculate, that function is fine. It doesn't have to change at all. Calibrated, it kind of does because we have the literal, not the literal, but the references to add and mul in there. So let's say this takes the choices of operations. So this is like in part 1 we're just going to pass it add and mul, and then in part 2 we pass it add mul in the other one. So how can we do that? I'm going to say we could do a lambda, but that's pretty ugly. I'm trying to make this one look nice. No indexing, 1 lin, which I don't like, and then let's try to avoid lambdas as well. So let's bring in partial. Let's say from functools import partial. So we'll make a partial calculate that once has 2 operations and once has 3. Okay, so we'll go partial of this where operations equals add mul. Okay, and then I think we need another parentheses. Let's try that. I want to run it, see if I ruined part 1, and if I didn't, then we can do part 2. Hey, look at that. We still got the same answer. Great. So now part 2 says, hey, we're going to do the same thing, except we add in a concat function. And what is the concat? Well, it's kind of like these. Is that like a keyword or something that was suggested? I don't know. Maybe I should call it cat, so it's 3 letters. And some languages do use the word catenate instead of concatenate. I wonder what the theory behind that is. So we're going to return F, A, B to squish them together, and then int that. I believe F strings are more performant than calling the str function, but maybe I'm losing it. Let's test that out on the example before we do the big data. So this is 11,387. Let's see if that's right. Yeah, it was right. Okay, so look how long that answer is, and just knowing that it's going to have to convert to strings every time, it's going to have to check a lot more possibilities every time. Yes, this is going to be slow, but let's run it and see how slow. Okay. Oh, where's my print? I don't really need the print. But you can see it's still trying to do part 2 because our calculate function has no idea how many operations it gets or what they are, it just does it. And then our calibrated function has no idea what it is or how they are, it just uses it in the product. Okay, there we go. We got this answer after, I don't know, 20 seconds or something. This was interesting, especially because of the types. I really tried to focus on making these types that make sense so that even with a partial, even with passing along strategies to be called by another guy who calls another guy, the MyPy analysis can give me a clean slate with no red squiggles. When I tried this earlier, I tried lambdas, I tried import operator, and it was never quite happy until we landed on something like this. So check it out. This was a very fun problem whenever you're trying to write something and make it look nice and make it typed and have, like, that's as far as we indent. We don't indent for I, for J, for K, and doing it all across the dang screen. We keep it nice and mostly readable. The only thing I really don't like is the name test, but I use that because that's what they use in the description. So we'll see how it goes. Thanks.